Hello students, let us today study about the generation of sinusoidal voltage and also let us see how to derive the equation of alternating EMF. But before going into this part, let us first understand some important definitions. Let us see what do you mean by an alternating quantity, a waveform, what do you mean by a periodic time frequency, and what do you mean by an alternation and cycle. So first let us see what do you mean by an alternating quantity. So alternating quantity means any quantity which acts in alternate positive and negative directions and whose magnitude changes in definite intervals of time. So both the sequence of changes in the negative is identical with the sequence of change in the positive. So say I can depict an alternating quantity like this. So it has both alternate positive and in the negative directions you can see the identical changes. Next let us see what is a waveform. So in simple words, waveform is nothing but a graph. So since we are talking, we will be speaking here about the alternating quantities such as voltage and current. Let me define the waveform using these quantities itself. So waveform is nothing but a graph between an alternating quantity and time. So that is called as a waveform. So here if we are going to depict the alternating quantity, then we will be depicting voltage or current along the y-axis, whereas the time along x-axis. Next, let us see what is an instantaneous value. So instantaneous value means finding out any value of the alternating quantity at a particular instant or at a particular amount of time, say equal to t equal to 0 seconds or say t equal to 2 milliseconds. So at a particular time, finding out the value of that particular alternating quantity is called as an instantaneous value. Next is alternation. So when the alternating quantity goes through one half cycle, it is said to be completing an alternation. So one half of the cycle. So it should complete full one uh, positive set of values or negative set of values. So any one, either the positive or the negative. So half of the cycle is called as an alternation. Next is periodic time. So time taken in seconds to complete one cycle by the alternating quantity. So time in seconds to complete one cycle. So what do you mean by a cycle? Cycle is nothing but full set of positive and a negative value. This is called as a cycle. So time taken in seconds to complete this one cycle is called as a periodic time. So periodic time is denoted by the capital letter T. Next is frequency. So frequency means number of cycles completed per second. So the relationship between the periodic time and the frequency is given by T is equal to 1 by F, where F is nothing but the frequency, which is denoted by small letter F. So next let us go and see how is the sinusoidal voltage generated. So let us see how the generation of sinusoidal voltage happens. So generation of sinusoidal voltage can happen using two types of methods, that is So first let us say generation of sinusoidal voltage. So you can generate the sinusoidal voltage either by rotating the coil in the magnetic field, or you can rotate the magnetic field within the stationary coil. So rotate magnetic field within the stationary coil. So here today, to find out the equation of alternating E.M.F, so we'll be making use of one of the methods. So what we will be doing to find out the equation of alternating E.M.F is, we will be rotating the coil in the uniform magnetic field. So let us see how to find out the equation, how to derive the equation of alternating E.M.F. So equation of alternating E.M.F. So we are going to consider a coil of n number of turns. So first draw the figure. So I'm going to consider the coil with n number of turns, which is going to rotate in a uniform magnetic field. So we are assuming that the coil is rotating in the anticlockwise direction. So with velocity, angular velocity of omega radians per second. So omega angular velocity. So this is the flux distance. So uniform magnetic field. So we are going to measure the time. Now the time will be measured from the instant of coincidence of the plane of the coil with the x-axis. Now at this instant, what happens is the maximum flux, that is the phi max, will link with the coil. Now what happens when the coil is rotating? Now when the coil is rotating, the flux linking with the coil will also change, and because of which the EMF is induced in it. Now let the coil be rotating, and when the coil is at an angle theta equal to omega t, at time t seconds, we are going to assume this position as shown. So for all the measurements and all the equations here, so we already know theta is equal to omega t. Now when the coil is in this position, so what happens is the maximum flux is acting vertically downwards, right? So you can see here, the maximum flux is acting vertically downwards. Now this flux can be resolved into two components. One is a perpendicular component, yes, one is a horizontal, and one is a vertical component, right? So see, one will be this component and another one will be this component. So one is resolved as the cos omega t component, another one is the sin omega t component. So if this is the phi max cos omega t component, then this one will be the phi max sin omega t component. Now what happens is, the phi max sin omega t component is actually parallel to the plane of the coil. Now what happens when the component is parallel to the plane of the coil? You know, there will be no flux induced because both are parallel. Phi max sin omega t is parallel to the plane of the coil, whereas phi max cos omega t is perpendicular to the plane of the coil. Now the perpendicular component is the only one which will induce EMF in the coil. The one which is parallel, it will not induce any EMF in the coil, so we can just neglect it. So from this, we can derive what is the flux linkages. the flux linkages of coil at that instant when the coil is at theta equal to omega t. So at that time, flux linkages can be calculated as number of turns into the flux linking. Now I have already told we are going to consider a coil which is having n number of turns. So n into flux linking. So flux linking at the point when theta is equal to omega t is phi max into cos omega t. So we need to remember this. So let me mark it as star. Okay. Now, let us just remember what the Faraday's laws of electromagnetic induction. So what does the Faraday's laws of electromagnetic induction state? So according to the Faraday's laws of electromagnetic induction, it states that the EMF induced in a coil is equal to the rate of change of flux linkages of the coil. So the instantaneous EMF, that is E, induced in the coil can be calculated as minus d by dt of flux linkages. So flux linkages we have already derived previously. So it is nothing but minus d by dt into n into phi max into cos omega t. So n into phi max is nothing a constant, minus n into phi max into the derivation of cos omega t with respect to t. Now what is the derivation of cos omega t with respect to t? So it will be nothing but minus omega into sine omega t. So substituting that, so minus n into phi max into minus omega into sine omega t. Since it is minus into minus will be plus. So n into phi max into omega into sine omega t. So this is the EMF induced. Let me mark it as equation 1. Now from this equation you can say that the EMF induced E will be maximum when the coil is rotating or when the coil is at angle 90 degree. So you know already sine 90 degree is equal to 1. Therefore the maximum EMF EM can be written as EM is equal to n into omega into phi max volts. So this is the maximum EMF. So let me mark it as equation 2. Now let me substitute equation 2 in 1. So substitute equation 2 in 1. So what will you get? So E will be equal to EM sine omega t. So let me take this as equation 3. Now we already know that theta is equal to omega 2. Substitute that in the above equation. So you will get E is equal to EM sine theta. So that let me take it as equation 4. Now we know that omega is equal to 2 pi f. So substituting this in equation 3, you will get E is equal to EM sine 2 pi f into t. So let me take this as equation 5. Now again, we all have already studied that the relationship between the frequency and the periodic time is given by f is equal to 1 by t. So if you substitute that, you will get E is equal to EM sine 2 pi by t into t. So let me take this as equation 6. So these are the different type of equation through you can write the EMF equation. So let us now draw the graph of the sinusoidal EMF. Now EMF induced is varying as the sine function of the time angle, right? So we already know the we will get a waveform with a sinusoidal shape. So if you're going to plot the EMF, the graph of EMF, then you will get you will get a sinusoidal waveform. So omega t, and this is the generated EMF E. So this is the amplitude EM. This is the amplitude, and you know this one full is one cycle, right? So this is how the graph of generated EMF will look like. So thank you.